background so that if, let's say, you are moving on to the A level next year, you have an idea what is this organic chemistry all about. All right, so that's my plan. And today we're going to go into the topic on alkenes. All right, the topic on alkenes. But before that, we have to finish up this worksheet 4.3 that I've shown on the screen. And if I didn't remember wrongly, we need to finish up question, let's see, question 16 to the end, right? That was actually an assignment, the homework that was given to you. And also the worksheet 6.1, we have left with question 5 to 7. So a bit of work to do, so we're going to go a little faster. And what about worksheet 6.2? Did the receptionist give you a copy and put it in your link for worksheet 6.2? Have, right? Yes, okay, thanks, Nicole. So that will be done after we have gone through the theory on the alkenes. All right, okay, so are you happy about the extension, 1 month of a break? Hooray.
I don't know.
Don't know, mixed feeling, right? Wish to go back to school, but yet so boring to stay at home, isn't it? Yeah, okay. And also don't really wish to go back to school because going back to school means a lot of homework to do. Staying at home is still so good. So a lot of mixed feeling. What about you, Mabel?
Okay.
Okay, you're also very neutral. Don't know what to say as well. I was really surprised that it has been extended for 1 month because I thought that it would be like an extension for 2 weeks. But nevertheless, we have to make full use of the changing situation, make the best out of it, and then learn positively. Okay, so let's take a look at the questions from worksheet 4.3. So I'll give you the answers for questions 16 to 30. And I assume you have done everything. Actually, 16 to the end, not 16 to 30. Okay, so did I give you all the answers already? Everything? No, right? Have I given you the answers? Or where did I stop?
15.
16, okay. Then those after 16, I've not given you the answers, right?
16 haven't yet, then onwards.
Yeah, okay, onwards. Okay, sure. All right, so here are the answers. Question 16 is A. 17 B. You can look at the answers on the screen. All right, now I'll slowly scroll up. Now just look at the answers. Later I'll go through with you the questions. All right, check the answers. Okay, are you done with the answers? Can, okay, now let's take a look at the questions. You could have some mistakes or some queries that you need to ask. So which particular questions would you like me to go through? I think 17, 16, and 17 are quite okay. 18. 20. Yeah, I think the first 5 are quite all right. Any questions on those 16 to 20 on page 8? Nope. Okay, silence means consent, so I'll move on. 21. Now keep in mind that question 21, you're asking for concentrated sodium chloride solution. So when we talk about concentrated solution, the anions that will be discharged will always be the chloride ions, not hydroxide ions. All right, and moreover, we are using the copper electrodes. Copper electrodes are active electrodes. And what will happen at the anode, if you are using active electrodes, is that this copper electrode will start to get oxidized. That's why there's a decrease in the mass. All right, so that's why A is the answer. Now I'll go through question 22. That is the mole calculation. All right, involves the mole calculation. So you can see that for this copper 2 sulfate, all right, the copper 2 sulfate electrolyte, is found to have an increase in the mass by 12 grams at the negative electrode. So negative electrode is actually a cathode. So we're going to find out what is the amount of gas that's produced at the positive anode. Okay, let me share with you the calculation. All right, so first of all, you have to write out the half equations that happens at the cathode. So we know that this is the reduction half equation that forms the copper matter. So we have 12 grams of the copper matter that is produced. So there'll be 12 divided by 64. So simply take the mass 12 grams divided by the AR64 to get it to 0.1875 moles. Okay, 0.1875 moles. And you can see that the number of electrons involved is actually twice as much as that of the copper in terms of its mole ratio. So the number of moles of electrons will therefore be 0.1875 times 2, which is 0.375 moles. Okay, 0.375 moles. So what about at the anode? What kind of half equation would that be? So 4OH minus to give 2H2O plus O2 plus 4E minus due to the discharge of the hydroxide ions. All right, so since hydroxide ions, the discharge of hydroxide ions involve 4 moles of electrons, we can see that this number of moles of electrons, 0.375, is also equivalent to the number of electrons that is being lost by the hydroxide ions due to the discharge of the hydroxide ions. So what do? Now we can use this information to find the number of moles of oxygen gas that's produced by taking 0.375 divided by 4. Okay, so I'm going to divide by 4 because of this 4 ratio versus 1 ratio of oxygen. So we have this as 0.09375 moles. And how do we find the volume of oxygen? Multiply by the molar volume, which is 24 dm cubed under room temperature and pressure. And that will be 2.25 dm cubed. Understand? All right, so you have to write out the half equations correctly. All right, and the total number of moles of mole ratio of the electrons involved is actually 4 is to 1 between the electrons and the oxygen. So we get the answer B. Okay, back to the question. If there's any question, please stop me. All right, so take note on this. Any more questions on page 9? All right, let's move on to page 10. So as I've mentioned before, if you look at question 25, if they show you two test tubes of the same volume of gas that's being collected, it means that the volume of the gas collected is actually 1:1. Okay, so if you look at the answer, question 25, it is C, because in a concentrated electrolyte, Cl- will be discharged to form the chlorine gas, H+ ions will be discharged to form the hydrogen gas, and both will be collected in the ratio of 1:1.
What is the difference between a molten and an aqueous solution?
Oh, molten means liquid.
Oh.
Yeah, molten and liquid are the same. Aqueous means that you have to add water to turn it into a solution, to dissolve the to dissolve the soluble ionic salt and turn it into solution. So if it's molten electrolyte, there'll be no H+ or OH- ions present, because H+ and OH- ions comes from water. Got it? Okay, I would like to go through question 27. All right, so question 27. Why is the answer B? How come there's a constant mass? Now, because the question says that it consists of magnesium electrode and an iron electrode, okay, and it's connected by a copper wire placed in an electrolyte of the sodium sulfate. So how about the electron flow when we are using an iron electrode and this magnesium electrode? Definitely electrons flow from the more reactive matter to the less reactive one, right? Okay, so it flows from magnesium electrode to the iron electrode. So you should expect the magnesium to get depleted, to be oxidized, to form the Mg2+ ions. So what will happen at the iron electrode? Will there be an increase in the mass of the iron electrode? No, because in the aqueous solution, we have the sodium ions and the H+ ions, right? Which ions are more preferred to be discharged? It's actually H+ ions. So H+ ions will be discharged at the iron electrode to form the hydrogen gas. So the mass of the iron will still remain the same. But what would you observe is that there will be effervescence of hydrogen gas being produced. You got it? Right, so that's why B is the answer. What about 28 to 30? Mabel, are you okay with me? With my pace? Would you follow through? Can, okay. How are you, all right? Okay. Okay, now I would like to go through question 28. Now remember we said that if the electrode potential or this potential voltage, right, gives a negative value, it indicates that the current is flowing in the opposite direction. Like if you compare cell 1 and cell 2, cell 1 gives you a positive potential. Why? Because the electrons are flowing from the more reactive matter, which is chromium to cobalt, right? Chromium to cobalt. Now, in the cell 2, we are still using chromium at the electrode 1, but we put a more reactive matter such that its reactivity is higher than that of the chromium. So you see, electron flows from aluminum to the chromium in the opposite direction. That's why your potential becomes a negative value. All right. So from here, we can arrange the order of reactivity, knowing that aluminum is the most reactive matter, followed by chromium, and then followed by cobalt. Now, if you look at cell 3, let's decide the reactivity between cobalt and nickel. Now, cobalt is actually more reactive than the nickel because now it gives you a positive potential. It means that electron flows from electrode 1, that's the cobalt, to the nickel. Do you understand the implication or not? All right, do you understand? Now the negative values, the negative sign tells you the direction of the electrons flow. So if you compare between cell 1 and cell 2, we know that the flow of electrons has changed its direction. But the question is, how do we know which one is more reactive and which is less reactive? We look at this chromium to cobalt, the electropotential positive, right? Chromium, electrons flow from chromium to cobalt. But in the cell 2, we didn't change the position of the chromium. Chromium is still put at electrode 1. But what happened is electron flows in the opposite direction. It flows from aluminum to chromium, as indicated by the negative charge. So this tells you that chromium is definitely more reactive than, this tells you that aluminum is definitely more reactive than chromium. You got it? Yeah, okay. Then what about the cell number 3? Now the cell number 3, now they put the cobalt in the electrode 1. They put the cobalt in the electrode 1, meaning that cobalt is more reactive than nickel because it gives a positive potential value. You get what I mean? Yeah, so that's how you deduce. All right, and hence we have the answer as they want us to arrange it in increasing order of reactivity. Yeah? Okay, so you have the answer is D, from the least reactive to the most reactive. Make sense? Okay, now this kind of questions is also quite commonly asked as well. So just take note. Okay, now question 29. Oh yeah, 29. Interesting question as well. So for question 29, because of these words, there were no decomposition products at the electrodes. No decomposition products. What does it mean? That means we don't have to add water, we don't have to carry out any chemical reactions to cause the electrical conductivity to take place. So it's definitely mercury, because mercury is a matter. Matter conducts electricity because it has free moving electrons. But if you look at the rest, like the aqueous sodium chloride or the molten sodium chloride, what do you have to do to this? When they are solid, they cannot conduct electricity because their ions are held in a fixed position in the giant lattice structure. But we have to add water, right? We add water to turn it into a solution. By adding water, you're breaking down the giant lattice structure. All right? By turning into the molten sodium chloride, you are melting it by increasing the surrounding temperature. All these are additional actions that causes the changes in the giant lattice structure. That's also the same like decomposing the ions. All right, so that's why B is the answer. And moreover, mercury is an element, right? An element is already in their simplest form. That's why if you were to carry out electrolysis on an element, there will definitely have no decomposition products at all. Unless you are decomposing a compound. Make sense? All right, so take note on this. Question 30, also nothing much to add on. On your side, any questions from 31 to 32 on page 12?
I haven't do 30 onwards.
Oh, you haven't done 30 onwards, is it? Okay, never mind. No worry. We can still run through. What about Harry? Any questions?
I haven't done it yet.
You haven't done. Okay. So then I'll go through with you, huh? I will pick those difficult ones to run through. Now question 30 is not a difficult question. You will know that, you should know that the ethanoic acid sugar solution, solid lead to bromide, cannot conduct electricity at all. right? Because they don't have the mobile charged particles to conduct electricity. So that left you with option B, right, option B, which is possible to cause the bulb to be lighted up. All right, and then for question 31, does not yield any gaseous product. So if you look at the option B, they're using copper electrodes. Now, copper electrodes are active electrodes. So that means at the anode, it will get depleted. There will have a decrease in the mass of the copper anode. Right? Then what happened to the copper electrode? Sorry, the copper cathode. So then you have to decide what are the cations in the electrolyte that can be discharged at the cathode. So we have the Ag plus and H plus. Now between Ag plus and H plus, which is more preferred to be discharged, Mabel?
H plus.
No, it should be Ag plus. So you have to memorize the reactivity series of the matter. The silver comes below the hydrogen. Remember? Okay. So that's why the silver ions are more preferred to be discharged to turn into or to be reduced to the silver matter. So you will see silver matter being accumulated at the copper cathode. All right? That's why there's no gas produced at both electrodes. Okay, now for question 32, this picture shows the volume of the gas. So, as in the volume of the gases being collected in the ratio of 2:1. This is 2, this is 1. All right, so it's definitely an electrolysis that is done on the dilute acid. Because in the dilute acid, we will have the H plus ions and the OH minus ions to be produced. So what is this volume 2 refers to? It's actually the hydrogen gas. If you can't remember, we said that in any dilute acid, the H plus ions will be discharged at the cathode, right, to undergo reduction according to this half equation. Then at the anode, we have the hydroxide ions to be discharged to give the oxygen gas. So when you sum up these two half equations, you will see that the volume of the hydrogen gas that's produced versus the oxygen gas is actually 2:1. You see it? All right, so back to the question. The anode will produce the oxygen gas that has a volume of 1 ratio. Then the cathode will produce a volume of two volumes of the hydrogen gas. Get it? Okay, so such a picture have to keep in mind and be able to tell what kind of gases are produced. Okay, let's move on. Question 33 onwards. You see, this is an electrolysis. What will be observed at the anode? So anode is the copper electrode. It's an active electrode. So being an active electrode, you will see that the copper matter should be oxidized, right? Okay, so when the copper metal oxidizes, what will it turn into? It will turn into the copper 2+ ions and gets into the solution. That's why the solution turns blue. Make sense? So whenever there's a discharge of the Cu2+ ions, whenever there's a formation of the Cu2+ ions in the solution, it it will always cause the solution to turn blue. All right? Okay, so why does lead form at the cathode? Question 34. Well, see, this is the molten lead-2 bromide. In the molten lead-2 bromide, we only have two kinds of ions that are present, which is the lead-2 plus and the Br minus ions, right? So at the cathode, you will definitely have the Pb2 plus, right? Pb2 plus to be discharged. Agree? Okay, so when Pb2 plus are being discharged, that's the positive lead-2 ions are discharged at the cathode. So that's why lead matter will be formed. Okay, so C is the answer. Okay, this one. Now, question 35, I just want you to take note on the option D. Can you see that they use the magnesium iodide, concentrated magnesium iodide? Right now, I mean, you may not have seen this type of electrolyte in most of the questions, but then magnesium iodide has similar properties as magnesium chloride. So we know that in a concentrated solution, the halides, right, the halides, in this case, the iodides, will be discharged, will be more preferred to be discharged. So if you see this kind of question and they want you to write the half equation, how would you write it? Okay, so MgI2 concentrated. Right, so at the anode, we will have the I minus to be discharged to undergo the oxidation to form the iodine by losing 2 moles of electrons. So this was the aqueous solution. This will also be aqueous. All right, so you will see reddish brown. Okay, reddish brown iodine being produced at the anode. Then what about at the cathode? Now Mg2 plus cannot be discharged because it's a relatively reactive matters. Reactive matters ions cannot be discharged easily. So instead we have the H plus ions to undergo reduction to form the hydrogen gas. All right. So these are the two half equations that will take place when we use the magnesium iodide, the concentrated magnesium iodide solution. So you can see that as more and more I minus and H plus they are being removed, what's left behind will be Mg2 plus and the OH minus ions. So this will form an alkaline solution. Right, the resultant electrolyte will become more and more alkaline. That means there will be an increase in the pH. (36), anyone is 36? Whenever they say that concentration of the copper 2 sulfate remain constant, concentration remains constant, means that the anode, all right, the anode must be an active electrode. So if you look at this copper, right, see this copper anode, right? We know that this copper anode will get discharged, right? It will get oxidized to form the copper 2 plus ions and get into the solution. And at the same time, the copper 2 plus ions from the electrolyte will get discharged towards the platinum electrode. So there is no change in the concentration of the copper 2 sulfate. It will just remain constant in terms of its Cu2 plus ions concentration. Because when this copper metal gets oxidized, it forms Cu2 plus. At the same time, Cu2 plus from the electrolyte or from the copper 2 sulfate gets discharged towards the platinum. So one goes into the electrolyte goes towards the platinum, no change. And they are both exchanging the same amount of electrons. All right. So nothing to add on to this. Yeah, for question 38, you see this is another electrolyte, rubidium iodide. So if it's a rubidium iodide, it is also referring to the similar compound like sodium chloride, any group 1 metal halides. So you should expect, because it's concentrated, you should expect iodide ions to be discharged and H+ ions to be discharged at the anode and the cathode respectively. Now question 39 is something harder. So let's run through. 39, you should have an answer of A. Okay, let me change the screen first. So when you read these questions, keep in mind that this is the electrolyte, zinc chloride. And what are they using? They're using the iron electrodes. Okay, the iron electrodes. So iron electrodes, do you consider them as the active or inert electrode? Hurry. Are iron electrodes active or inert electrodes?
Inert.
Sorry?
Inert.
Sorry, come again?
Inert electrode.
Oh, no. Iron electrodes are active electrodes. Now, in electrolysis, inert electrodes, there are only 3 kinds. Graphite, carbon, and platinum. Right, so iron electrodes are considered to be active. That means at the anode, you will have the iron metal to be oxidized to form the iron 2+ ions by losing 2 moles of electrons. Okay, let me share with you how to write the half equation. Okay, this is the half equation. Because iron is an active electrode, you should expect the iron to undergo the oxidation to form the iron 2+ ion. Understand this part? Okay, then what about the cathode? Now the cathode is actually an active electrode, which is also using the iron metal, right? But we said that at the cathode, reduction is always taking place. So you have to look at what kind of ions are present in the electrolyte. Now, since we are using the zinc electrolyte, zinc chloride electrolyte, we have the zinc 2+, H+ ions that are present in this electrolyte. Which is more preferred to be discharged? H+, right? So you should have the H+ ions to be discharged to form the hydrogen gas. This is the half equation that will take place at the cathode. If you look at the question again, or the options, we want you to find the statement as false, right? Colorless of gas are formed at the positive electrode. Oh, this is definitely not true, because if you have identified that iron electrodes are active electrodes, you should know that iron electrodes, especially at the anode, will get oxidized. Nothing will be formed at the iron anode. In fact, iron metal will get depleted slowly. Okay, let's run through the other options. pH of the solution gradually increases. Will it be gradually increased? True what? Right, because H+ ions are discharged at the cathode. Then we left with hydroxide, so hydroxide ions makes it more alkaline. Okay, and then the solution gradually turns green. Why does it turn green? Because of the formation of the Fe2+ ions. Right, the formation of the Fe2+ ions that causes it to turn green. Okay, and then D, zinc ions are attracted to the negative electrode. This is also true, but it is not an immediate observation. After all the H+ ions are being discharged, then the zinc 2+ ions will slowly be discharged. Or zinc 2+ ions will be attracted towards the negative electrode. Okay, so remember, inert electrodes are only 3 types: carbon, graphite, and platinum. These are the inert electrodes that are used in the electrolysis, and they will not take part in the chemical reactions immediately. Got that? Okay, then question 40 is also another popular commonly asked questions, very popular questions. You see they bold the word always, right? Okay, and then it says that